Hello everyone, welcome to today's session. Let's continue our discussion and solve the Opsc Pgt physics question paper from 2021. In the previous videos, we have solved up to question number 75. So in this video, we will start from question number 76. Before we begin, I want to remind you to note down any extra important information we discuss related to each question. These points will be very helpful for your upcoming exams. We are not just solving 20 or 25 questions, we are discussing all the related and expected questions that could appear in the upcoming exam. So let's get started. And if you found this video helpful, please like and comment. Okay, let's start. Question number 76. The circuit in which the present output depends only on the present input. That is your combinational circuit. Okay, so your correct option is option B. Okay, so for example, you can see what are combinational circuit? Your adder circuit, subtractor circuit, then encoder, okay, decoder, or your multiplexer, demultiplexer. All are the examples of combinational circuit in which the present output depends on the present input only, and there is no feedback or memory element. But in case of sequential circuit, if you see, in this type of circuit, the output depends on the present input as well as past input. Okay, so for example of sequential circuit, you can see your flip-flop, okay, flip-flop, then your resistors, then counters. Okay, in all these you will found a feedback element or a memory element. 77. The number of MOS transistors required to form SRAM is 6. Remember, for SRAM, that is your static RAM. Okay, static random access memory. So we require 6 MOS transistors. There is also another type, that is DRAM, and for DRAM, that is dynamic RAM, we need only one transistor. Okay, and if they ask about their speed, so SRAM is faster than the DRAM. Okay, so remember, SRAM is faster in terms of speed operation. Next, 78. The transistor used in IC which are not driven into saturation belongs to bipolar unsaturated logic family. Okay, so A is your correct option. 79. The storage capacity of a shift register depends on number of stages or number of flip-flop present. Okay, so basically if you see, number of stage or flip-flop represents one bit of storage capacity. That means one stage or one flip-flop or one stage represents one bit of storage capacity. One bit means 1 or 0. For bit, if you see, bit is the smallest unit of storage capacity. Smallest unit. Okay, so here I have a questions for you, like how many bits equals to one nibble, and how many bits equals to one byte? Please write down in the comment section for these two questions. Okay, how many bits is one nibble and how many bits is one byte? Next, 80. The oscillator which uses both positive and negative feedback is your Wien-Bridge oscillator. So A is your correct option. 81. The main difference between the oscillator and an amplifier is oscillator requires no input signal. Okay, so B is your correct option. So oscillator is an electric circuit which gives output without input. Okay, so this is the main difference. Next, 82. For bit comparison purpose, the gate that can be used is two input exclusive NOR gate. So D is your correct option. If you see the output of exclusive NOR gate, that is XNOR, output is for input A and B. Output is AB plus A bar B bar. So if you see its truth table like A, B, Y for 0, 0, 1, that means when both the inputs are low, it is high. For 0, 1, it is 0. For 1, 0, it is 0. And for 1, 1, again it is high. So when both the inputs are low, output is high. And when both the inputs are high, output is high. Okay. So this XNOR is used for the comparison purpose. Similar way, you should remember the output for XOR gate, exclusive OR gate. That is output Y equals to A bar B plus A B bar. Next, 83. Which among the following can be used to develop an inverter gate? That is your transistor. Okay, so transistor can be used to develop an inverter gate. Okay, so let me give you one question here. Like you have NAND gate, NOR gate, okay, then AND gate and XNOR gate. Okay, so can you tell me using this gate we have to form a NOT gate or inverter gate? Okay, so using which gate we cannot design NOT gate? So let me write down the question here. Using which gate we cannot design an inverter gate? Okay, so please write down the answer in the comment section. Okay, let me give you a hint here. See, NAND and NOR gates are universal gate. So using these two gates, we can implement any type of gate. Okay, so now you have the option, two options, AND or XNOR. So you have to choose with which gate we cannot design a inverter gate. Next, 84. Which of the following can be a wave function? So basically that means acceptable wave function. Okay, so we know for a acceptable wave function that should a single value. Okay, that should have this should be continuous and that should satisfy the normalization condition. That means that should be square integrable. That means the integral at all space will having finite value. Okay, so you can check only sin x is satisfied because cos 10 cos x do not satisfy the normalization condition. Okay, so only sin x is acceptable here. That is the wave function. Next, 85. For a free particle, which among the following is true? The solutions are not energy eigenfunction. No. The solution of a free particle we know is a eigenfunction of energy. Okay, so let's check other options. The solutions of the Schrodinger equation are both energy and momentum eigenfunction. Option C is correct. You can see here for a free particle, in Schrodinger equation we get the its solution we get the linear combination of exponential plus minus ikx. So you can check this linear combination will satisfy both the eigenvalue equation for both the momentum operator and energy operator. Okay, so momentum is our minus IH cot del y del x. Okay, and energy is IH cot del y del t. So if you will check minus IH cot del y del x, I k x. Okay, so this will be minus IH cot ik exponential ik x. Okay, so this will give you h cot k exponential ik x. You can see this is a constant value and this is the same wave function. And we know if a function that is a psi equals to lambda psi, that means if an operator operates on a wave function and gives us constant multiplied with the same function, then we will call this as a eigenvalue equation and this function is an eigen function of this operator a. So here you can see we are getting the same result. So this wave function of free particle or the solution of the free particle in Schrodinger equation is a eigenvalue of momentum. Similar way, you can check for the energy, that will also satisfy the eigenvalue equation. Okay, so these solutions of the free particle are eigenfunctions of both energy and momentum operator. Next, 86. The maximum current which can flow through a 60k ohms resistor rated 6 watt. Okay, so resistance is 60 kilo ohm and power is 6 watt. Okay, if you see power is given by Vi, that means I square R. Okay, so from here we can find I as square root under P by R. That means square root under P. P is your 6, then R. R is 60 into 10 to the power 3. Okay, so 6 cancel. This will give you 10 to the power minus 2 ampere, or this is equals to 10 milliampere. Okay, so C is your correct option. 87. The residue of hot Z at Z equals to 0 is. Okay, see. So complex function f of Z is hot Z. This we can write as cos Z by sin Z. Okay, and Z equal to 0 is a pole here, and this is a simple pole of order 1. Okay, this is simple pole. So you need to remember how to find the residue of a complex function for a simple pole. Okay, so there are two types of formula you can remember. Like for a simple pole of f of Z, you can remember residue at Z equals to A. A is the simple pole, is directly limit Z tends to A, Z minus A times f of Z. Okay, there is another formula for to calculate the simple pole, and that is if a function, complex function is given in this way, phi Z by psi Z, phi of Z by psi of Z, and A is a simple pole, and let's consider psi equals to A is 0. So in this case, you have to find the residue. So let me write here residue for this function. Okay, so residue for this function at Z equals to A will be phi of Z, phi of A divided by first derivative of psi at Z equals to A. This will be your residue for this type of function. You can check here Z at Z equals to 0. Cos 0 is 1, but sin 0 is 0. That is 1 by 0. So your denominator part is 0. So in this case, you have to define the residue at Z equals to 0 as cos 0, that means 1, and first derivative of sin Z. The first derivative of sin Z will give you cos Z, and at Z equals to 0, that means cos 0, and cos 0 is 1. So 1 by 1 is 1. Okay, so your correct option is option A. In similar way, you should remember for the uh, pole of order n, how to calculate the residue of a complex function for a pole of order n. Okay, so for that pole of order n, residue at Z equals to A equals to 1 by n minus 1 factorial d to the power n minus 1 dz n minus 1 Z minus A to the power n f of Z. Okay, so this is for pole of order n. Next, 88. The rest mass of an electron is m naught when it moves with a velocity v equals to 0.8 c, then its rest mass. We know the mass will vary when the particle moves with a relativistic speed, and that mass is given by m naught divided by square root under 1 minus v square by c square. Okay, so this is m naught square root under 1 minus 0.8 square c square by c square. So c square will cancel out, 0.8 square, that means 0.64, and m naught 1 minus 0.64, that is 0.36, and square root of 0.36 will give you 0.6. So m naught by 0.6. So A is your correct answer. 89. If E1 is the energy of the lowest state of a one-dimensional potential box, of length A, and E2 is the energy of the lowest state when the length of the box is doubled. Okay, so let me write down the energy first for a one-dimensional potential box, and that is n square pi square h cot square by 2 m a square with length A. So for lowest state, energy will be pi square h cot square by 2 m a square. You can say these are the constant. So the variation with length is 1 by a square. Okay, so this is given first condition, and in the second condition, the length is doubled. Okay, so it will variate 1 by 2a square. That means 1 by 4a square. Okay, so E1 will be, or E dash. Okay, E dash is E by 4. Okay, so from, okay, so these are given E1 and E2. So let me write, this is E2 and this is E1. So E2 is equals to E1 by 4, or E1 will be 4 times E2. So E1 will be 4 times E2. Okay, so B is your correct. Next, 90. An electric current of 4 ampere flows through a resistance of 30 ohm. It is being cooled by running water and is kept at temperature 300 Kelvin. Change in entropy per second of the resistance. Okay, so from second law, even write down entropy change is Q by T. So Q here you can calculate here I square R. I is 4 ampere, that means 16 into 30, that is 480 joule. Now temperature 300 Kelvin, so del S equals to 480 by 300. Okay, so you can found this to be 1.6 joule per degree. Okay, so A is your correct answer. Next, 91. If the temperature of the sun increases by a factor of 4, then the total power radiated by the sun increases by a factor of. Okay, so from Stephen Boltzmann's law, we know power radiated is proportional to the fourth power of temperature. So in first case, it is proportional to T to the power 4. In second case, the temperature increases 4 times. So 4 T to the power 4. So it will be proportional to 4 to the power 4. That means 4 into 4 into 4 into 4. So 4 for 16, for 64, 64 into 4. That is 256. Okay. So C is your correct answer. 92. At low temperature, the electronic contribution of the specific heat of a metal is. We know at low temperature there are two contribution for a specific heat, and that is given as ATQ plus BT. One is from lattice vibration, okay, and that is proportional to Q of the temperature, and the other from the electronic contribution, and that is linearly proportional to T. So this is a linear function of temperature T. So D is your correct option. 93. The Bragg's law equation can also be written as, okay, so 1 in real lattice we know 2d sine theta equals to n lambda, and in reciprocal lattice you can express Bragg's law as 2 k dot g plus g square equals to 0. So option A is your correct option. Next, 94. The spacing between successive 100 planes in NaCl is 2.75 Armstrong. Spacing between planes, that is your D, interplanar spacing. So that is your 2.75 Armstrong. HKL value is 100. Okay. So Miller indices HKL equals to 100. Next, X-ray incident upon the surface of this crystal is found to give rise to first order Bragg reflection. Okay, so N value is 1, first order. Then in, at a grazing angle 30 degree, then the wavelength of the X-ray. Okay, so you can use this equation directly. 2d sine theta equals to lambda, N is 1. So D value is given. So from here, sine theta 30 degree, so sine theta will be half. So 2 into D is 2.75 into half equals to lambda. 2 cancel. So lambda equals to 2.75 Armstrong. So 2.75 Armstrong. C is your correct option. 95. The reciprocal lattice for a BCC lattice is FCC lattice. We have discussed this question many times. Similarly, for FCC lattice, reciprocal lattice is BCC lattice. For simple cubics, reciprocal lattice is same simple cubic. Next, 96. Among the following, which nuclear reaction is strong? Okay, so this is very important questions. Okay, you can find this type of question in all exams. Okay, so let how to check if which given nuclear reaction is strong nuclear reaction. So you have to check the conservation laws. Okay, so in a strong nuclear reaction, the charge will be conserved, baryon number will be conserved, lepton number will be conserved, spin will be conserved, and with that, the isospin third component will be conserved, strangeness will be conserved, isospin will be conserved. So you have to check all these with this four option. Okay, so I am leaving this question for you. Check with all option and write down in the comment section which one is the strong interaction. Okay, similarly, you should remember, like for electromagnetic interaction, isospin is not conserved. Okay, del S is conserved, del I3 is conserved, but isospin is not conserved. And in weak interaction, del I3 is not conserved, isospin is not conserved, and also strangeness is also not conserved. Okay, so you check with all these options. 97. The missing particle X in the reaction P plus Q is this. So here you have to find X, but what is this Q here? Okay, so let me write down this equation by taking here is P. Okay, so P plus pi plus N plus lambda naught plus X. Okay, so here in this reaction, you have to find X. So in this type of question also, you have to check for the conservation law. Like you can first check for your charge. Okay, so for charge, proton 1 1, this is plus 1, this is 0 0, this is see 1 plus 1 2, here in right hand side 1. So here also we need a particle which will give us charge plus 1. So you can check the option, all are having with plus 1. Next we will check with baryon number, like proton 1 1 0 1 1. So here we need a particle which is not a baryon, or we need baryon number to be 0. Okay, so can be that particle can be measured. Okay. Next, let us check with I3, third component of isospins. For proton, this is half half. For pi plus, this is plus 1. This is minus half. For lambda 0, this is 0. Okay, so in left hand side, I3 is 1, and here in right hand side, 1 minus of half. So we need a particle which will give us the I3 value to be plus half. Okay, and here you can check K plus will give you the isospin third component to be plus half. Next, also you can check the strangeness number. Like for proton, this is 0 0. For pion also it is 0 strangeness number. Then neutron it is 0. For lambda this is minus 1. So K plus will give you, this is minus 1. So K plus will give you plus 1 strangeness number. Okay, so for in this equation X can be K plus. Next, 98. The strangeness quantum number is conserved in, remember, strangeness quantum number is conserved in strong and electromagnetic interaction, and this is not conserved in weak interaction. So you can check option, this is conserved in strong and electromagnetic interactions only. So B is your correct option. Next, 99. The relation between the group and phase velocity of the particle is, okay, so remember Vg equals to Vp plus K dVp by dk. K is your propagation vector. Okay, K. Then in terms of K, this is the relation, and in terms of lambda, the relation is Vp minus lambda dVp by d lambda. Okay, so you can check the options. This A is your correct option. Next, 100. If the partition function is z, then the mean energy is given by minus del by del V ln Z. So you can check options D. D is your correct option. Okay, so let me ask you a question. Write down the expression for free energy F. Okay, what will be the expression of F in terms of Z? Okay, please write down in the comment section. Thank you for watching. So we have solved some of the most important questions from previous OPSC PGT physics exam. I hope the problem solving techniques we discussed will be very helpful in your preparations. Remember, consistent practice is crucial, so make sure to go through as many previous year questions as possible. If you found this video helpful, please give it a thumbs up, share it with your friends and subscribe to the channel for more such content. If you have any questions or need further clarification, leave a comment below. I will be happy to help. Stay tuned for our next video where we will be discussing more questions from OPSC Pgt. Good luck with your studies and see you next time. Thank you.